Triceratops was an herbivorous genus of ceratopsid dinosaur that lived during the late Maastrichtian end of the Late Cretaceous period, around 68 to 65 million years ago, in what is now North America. It was one of the last dinosaurs to appear before the great KT extinction event. Bearing a large bony frill and 3 horns on its large 4-legged body, and conjuring similarities with the modern rhinoceros, Triceratops is one of the most recognizable of all dinosaurs. The name Triceratops, which literally means 3-horned face, is derived from the Greek tri, meaning 3, and ceros, meaning horn, and ops, meaning face. Though it shared the landscape with, and was preyed upon by, the fearsome Tyrannosaurus, it is unclear whether the two battled the way they are commonly depicted in movies and children's dinosaur books. Although no complete skeleton has been found, Triceratops is well known from numerous partial specimens collected since the genus' introduction in 1887. The function of their frills and 3 distinctive facial horns has long inspired debate. Although traditionally viewed as defensive weapons against predators, the latest theories suggest these features were primarily used in display for courtship and dominance, much like the antlers and horns of modern reindeer, mountain goats, or rhinoceros beetles. Triceratops is the best known of the ceratopsids, though the genus' exact placement within the group has been a point of contention among paleontologists. 2 species, T. horridus and T. prorsus, are considered valid, although many other species have been named. Contents: 1. Description. 2. Classification. 2.1. Use in phylogenetics. 2.2. Origins. 3. Discoveries and species. 3.1. Number of species. 3.2. Valid species. 3.3. Doubtful species. 3.4. Misassignments. 4. Paleobiology. 4.1. Dentition and diet. 4.2. Functions of the horns and frill. 5. Depiction in popular media. 6. References. Description. Triceratops compared in size with a human. Triceratops have been estimated to reach about 8 meters, 26 feet long, 3 meters, 10 feet tall, and weigh 6.1 tons, or 1,400 pounds. The most distinctive feature is their large skull, one of the largest of all land animals. It could grow to be over 2 meters in length, and could reach almost a third of the length of the entire animal. It bore a single horn on the snout, above the nostrils, and a pair of horns approximately 1 meter, 3 feet 4 inches long, above the eyes. To the rear of the skull was a relatively short bony frill. Most other frilled dinosaurs had large fenestrae in their frills, while the frills of Triceratops were notably solid. Triceratops species possessed a sturdy build, with robust limbs and short 5-hoofed hands and 4-hoofed feet. Although certainly quadrupedal, the posture of these dinosaurs has long been the subject of some debate. Originally, it was believed that the front legs of the animal had to be sprawling at angles from the thorax in order to better bear the weight of the head. This stance can be seen in paintings by Charles Knight and Rudolf Zallinger. However, iconological evidence in Triceratops trackways and recent reconstructions of skeletons, both physical and digital, seem to show that Triceratops maintained an upright stance during normal locomotion, with the elbows slightly bowed out in an intermediate stance between fully upright and fully sprawling, as in the modern rhinoceros. This conclusion does not preclude a sprawling gait for confrontations or feeding. Classification. Triceratops is the best-known genus of the Ceratopsidae, a family of large North American horned dinosaurs. The exact location of Triceratops among the ceratopsians has been debated over the years. Confusion stemmed mainly from the combination of short, solid frills, similar to that of the Centrosaurini, and the long brow horns, more akin to Ceratopsini, also known as Chasmosaurini. In the first overview of horned dinosaurs, R. S. Lowell hypothesized 2 lineages, one of Monoclonius and Centrosaurus leading to Triceratops, the other with Ceratops and Torosaurus, making Triceratops a Centrosaurine, as the group is understood today. Later revisions supported this view, formally describing the first, short-frilled group as Centrosaurini, including Triceratops, and the second, long-frilled group as Chasmosaurini. In 1949, C. M. Stenberg was the first to question this and favored instead that Triceratops was more closely related to A. Rhinoceratops and Chasmosaurus based on skull and horn features, making Triceratops a ceratopsine, Chasmosaurine of his usage, genus. However, he was largely ignored, with John Ostrom and later David Norman both placing Triceratops within Centrosaurini. Subsequent discoveries and analysis upheld by C. M. Sternberg's view on the position of Triceratops, with Lehmann dividing both subfamilies in 1990 and diagnosing Triceratops as ceratopsine, Chasmosaurine of his usage, on the basis of several morphological features. In fact, it fit well into the ceratopsine subfamily, apart from its one feature of a shortened frill. Further research by Peter Dodson, both a 1990 cladistic analysis and a 1993 study using RFTRA, resistant fit theta rho analysis, a morphometric technique which systematically measures similarities in skull shape, reinforced Triceratops' placement in the ceratopsine subfamily. Use in phylogenetics. In phylogenetic taxonomy, the genus has been used as a reference point in the definition of Dinosauria. Dinosaurs have been designated as all descendants of the most recent common ancestor of Triceratops and Neornithes, i.e. modern birds. Furthermore, the bird-hipped dinosaurs, Ornithischia, have been designated as all dinosaurs with a more common ancestor to Triceratops than modern birds. Origins. For many years, the origins of Triceratops have been largely obscure. In 1922, the newly discovered Protoceratops was seen as its ancestor by Henry Fairfield Osborn, but many decades passed before additional findings came to light. However, recent years have been fruitful for the discovery of several dinosaurs related to ancestors of Triceratops. Zuniceratops, the earliest known ceratopsian with brow horns, was described in the late 1990s, and Yinlong, the first known Jurassic ceratopsian, in 2005. These new finds have been vital in illustrating the origins of horned dinosaurs in general, suggesting an Asian origin in the Jurassic and the appearance of truly horned ceratopsians by the beginning of the Late Cretaceous in North America. As Triceratops is increasingly shown to be a member of the long-frilled ceratopsian subfamily, a likely ancestor may have resembled Chasmosaurus, which thrived some 5 million years earlier. Discoveries and species. Triceratops skull, showing horns and frill, neck armor. Oxford University Museum of Natural History. The first named specimen now attributed to Triceratops is a pair of brow horns attached to a skull roof, found near Denver, Colorado, in the spring of 1887. This specimen was sent to Othniel Charles March, who believed that the formation from which it came dated from the Pliocene, and that the bones belonged to a particularly large and unusual bison, which he named Bison alticornis. He realized that there were horned dinosaurs by the next year, which saw his publication of the genus Ceratops from fragmentary remains, but he still believed B. alticornis to be a Pliocene mammal. It took a third and much more complete skull to change his mind. The specimen, collected in 1888 by John Bell Hatcher from the Lance Formation of Wyoming, was initially described as another species of Ceratops, but after Reflection Marsh changed his mind and gave it the generic name Triceratops, accepting his Bison alticornis as another species of Ceratops. It would later be added to Triceratops. The sturdy nature of the animal's skull has ensured that many examples have been preserved as fossils, allowing variations between species and individuals to be studied. Triceratops remains have subsequently been found in the American states of Montana and South Dakota, in addition to Colorado and Wyoming, and in the Canadian provinces of Saskatchewan and Alberta. Number of species. Within the first decades after Triceratops was described, various skulls were collected, which varied to a lesser or greater degree from the original Triceratops, named T. horridus by Marsh, from the Latin horridus, rough, suggesting the roughened texture of those bones belonging to the type specimen, later identified as an aged individual. This variation is unsurprising, given that Triceratops skulls are large, three-dimensional objects, coming from individuals of different ages and both sexes, and which were subjected to different amounts and directions of pressure during fossilization. Discoverers would name these as separate species listed below, and came up with several phylogenetic schemes for how they were related to each other. In the first attempt to understand the many species, Lowell found groups, although he did not say how he distinguished them, one composed of T. horridus, T. prorus, and T. brevicornis, the other of T. elatus and T. calicornis. Two species, T. serratus and T. eurycephalus, and suggesting that it linked the second and third lineages closer together than they were to the T. horridus lineage. This pattern was followed until the major studies of the 1980s and 1990s. With time, however, the idea that the differing skulls might be representative of individual variations within one or two species gained popularity. In 1986, Ostrom and Wellinofer published a paper where they proposed there was only one species, Triceratops horridus. Part of their rationale was that generally there are only one or two species of any large animal in a region, modern examples being the elephant and the giraffe in modern Africa. To their findings, Lemon added the old Lowell-Sternberg lineages combined with maturity and sexual dimorphism, suggesting that the T. horridus, T. procerus, T. brevicornis lineage was composed of females, the T. calicornis, T. elatus lineage was made up of males, and the T. obtusus, T. hatcherii lineage was of the pathologic old males. His reasoning was that males had taller, more erect horns and larger skulls, and females had smaller skulls with shorter, forward-facing horns. These findings, however, were contested a few years later by Catherine Forster, who reanalyzed Triceratops material more comprehensively and concluded that the remains fell into two species, T. horridus and T. prorsus. Although the distinctive skull of T, now tentatively Triceratops hatcherii, differed enough to warrant a separate genus, she found that T. horridus and several other species belonged together, and T. prorsus and T. brevicornis stood alone, and since there were many more specimens in the first group, she suggested that this meant the two groups were two species. It is still possible to interpret this reasoning as describing a single species with sexual dimorphism. Valid species, skipped because contains too many words I don't know how to say. Paleobiology. Although Triceratops are commonly portrayed as herding animals, there is currently no solid evidence that they lived in herds. Unlike other horned dinosaurs, some of which are known from sites preserving dozens or hundreds of individuals, all Triceratops finds known at present preserve only solitary individuals. However, these remains are very common. For example, Bruce Erickson, a paleontologist of the Science Museum of Minnesota, has reported having seen 200 specimens of T. prorsus in the Hell Creek Formation of Montana. Similarly, Barnum Brown claimed to have seen over 500 skulls in the field. Because Triceratops' teeth, horn fragments, frill fragments, and other skull fragments are such abundant fossils in the Lancian faunal stage of the late Maastrichtian, late Cretaceous, 68 to 65 million years ago, period of western North America, it is regarded as among the dominant herbivores of the time, if not the most dominant herbivore. In 1986, Robert Bakker estimated it as making up 5/6 of the large dinosaur fauna at the end of the Cretaceous. Triceratops was one of the last ceratopsians to appear before the Cretaceous Tertiary extinction event. The related Diceratops and Torosaurus, and the more distantly related diminutive Leptoceratops were also present, though their remains have been rarely encountered. Dentition and diet. Triceratops was herbivorous, and because of their low head, their primary food was probably low growth, although they may have been able to knock down taller plants with their horns, beak, and bulk. The jaws were tipped with a deep, narrow beak, believed to have been better at grasping and plucking than biting. Triceratops' teeth were arranged in groups called batteries, of 36 to 40 columns with 3 to 5 stacked teeth per column, depending on the size of the animal. This gives a range of 432 to 800 teeth, of which only a fraction were in use at any given time. tooth replacement was continuous and occurred throughout the life of the animal. They functioned by shearing in a vertical to near-vertical orientation. The great size and numerous teeth of Triceratops suggests that they ate large volumes of fibrous plant material, with some suggesting palms and cycads, and others suggesting ferns, which then grew in prairies. Functions of the horns and frill. Triceratops head from the front, Triceratops head from the side. Juvenile and adult skulls. The juvenile skull is about the size of an adult human head. There has been much speculation over the functions of Triceratops' head adornments. The two main theories have revolved around use in combat or display in courtship, with the latter thought now to be the most likely primary function. Early on, Lowell postulated that the frills may have served as anchor points for the jaw muscles to aid chewing by allowing increased size and thus power for the muscles. This has been put forward by other authors over the years, but later studies do not find evidence of large muscle attachments on the frill bones. Triceratops were long been thought to have possibly used their horns and frills in combat with predators, such as Tyrannosaurus, the idea being discussed first by C. H. Sternberg in 1917, and 70 years later by Robert Bakker. There is evidence that Tyrannosaurus did prey upon them, as a Triceratops pelvis has been found with Tyrannosaur tooth marks and subsequent healing, indicating the wound was made while the animal was alive. In 2005, a BBC documentary, The Truth About Killer Dinosaurs, tested how Triceratops might have defended themselves against large predators like Tyrannosaurus, to see if Triceratops could have charged other dinosaurs, as would a modern-day rhinoceros. An artificial Triceratops skull was made and propelled into simulated Tyrannosaurus skin at 24 kilometers per hour, or 15 miles per hour. The brow horns penetrated the skin, but the blunt nose horn and the beak could not, and the front of the skull broke. The conclusion drawn was that it would have been impossible for Triceratops to have defended themselves in this way. Instead, they probably stood their ground when attacked by large predators, using their horns for goring if the predator came close enough. In addition to combat with predators using horns, Triceratops are classically shown engaging each other in combat with horns locked. While studies show that such activity would be feasible, if unlike that of present-day horned animals, there is no evidence that they actually did do so. Additionally, although pitting, holes, lesions, and other damage on Triceratops skulls, and the skulls of other ceratopsids, are often attributed to horn damage in combat, a recent study finds no evidence for horn thrust injuries causing these forms of damage. For example, there is no evidence of infection or healing. Instead, non-pathological bone resorption or unknown bone diseases are suggested as causes. The large frill also may have helped to increase body area to regulate body temperature. A similar theory has been proposed regarding the plates of Stegosaurus, although this use alone would not account for the bizarre and extravagant variation seen in different members of the Ceratopsidae. This observation is highly suggestive of what is now believed to be the primary function, display. The theory of their use in sexual display was first proposed by Davidashvili in 1961 and has gained increasing acceptance since. Evidence that visual display, either in courtship or in other social behavior, was important can be seen in the fact that horned dinosaurs differ markedly in their adornments, making each species highly distinctive. Also, modern living creatures with such displays of horn and adornments use them in similar behavior. A recent study of the smallest Triceratops skull, ascertained to be a juvenile, shows the frill and horns developed at a very early age, predating sexual development and thus probably important for visual communication and species recognition in general. The large eyes and shortened features, a hallmark of cute baby mammals, also suggests that the parent Triceratops may have cared for its young. Depiction in popular media. Main article, Triceratops in popular culture. The distinctive appearance of Triceratops has led to them being frequently depicted in various forms of popular culture, including films, computer games, and documentaries. They have notably appeared in the film Jurassic Park and its sequels, as well in 3 major dinosaur documentaries: Walking with Dinosaurs, The Truth About Killer Dinosaurs, and Prehistoric Park. They are famously known as Three Horns, and are so named in the Land Before Time animated film and its numerous sequels, due to the 3 prominent horns on their head and nose, which have become almost synonymous with the dinosaurs. The shorthand trike is another common informal name, and is also the name of the Triceratops character in the children's book series and television cartoon series Harry and His Bucketful of Dinosaurs. A reoccurring theme in children's dinosaur books is a climactic showdown or battle between Triceratops and T-Rex. As such, these two dinosaurs are often depicted and thought of as natural enemies. A memorable but anachronistic battle with Ceratosaurus substituting for T-Rex is featured in the 1966 movie 1 Million Years BC. Triceratops appears in video games either derived directly from the Jurassic Park series or similarly themed, namely the 1997 PC games Jurassic Park, Chaos Island, and Turok Dinosaur Hunter, and the 2000 PC and PlayStation game Dino Crisis 2. As well, it is a popular creature used in games designed by Nintendo, including Diddy Kong Racing and Star Fox Adventures. Triceratops, the species are not identified, is also the official state fossil of South Dakota and the official state dinosaur of Wyoming.